So this is one of the more challenging questions in coordinate geometry. So I'll read it out and then maybe give it a go with the three questions that are here, and then we'll go through it. So a line parallel to the x-axis meets the line PQ at the point B and passes through the point A, 1, 5, which is at the coordinates 1, 5. The equation of the line PQ is 3y equals 2x minus 5. Find the length of AB. Okay, so that's the first part that we need to give a go at. So the red line that we've got drawn here is actually the line 3y equals 2x minus 5. So that red line is PQ. And if a line is parallel to the x-axis and parallel to the x-axis and it goes through the point 1, 5, then it must be a horizontal line at the coordinate 1, 5. Which must mean that they intersect over here at some position. So this point over here must be coordinate B. Now, what the question says is find the length of AB. Now, at the moment, if we knew that coordinate, it'd be very easy. But algebraically, if we didn't have this diagram, we'd have to think about it. So all we'd do is we know that at B, the y value is going to be 5 because there's a horizontal line there. So if we take that equation, 3y equals 2x minus 5, substitute in 5, just do some rearrangements and solve for x, we get x equals 10. Okay, so that must mean that this coordinate here has an x value of 10 and a y coordinate of 5. And then the question is, well, what's the distance between A and B? Well, that's just the horizontal distance, right? So from 1 to 10, the length of AB must be equal to 9. So that's how we can work that part out. Okay, the next part's a bit trickier. It says find the sine of the angle between PQ and AB. Okay, this is where it gets a bit tricky. I'm going to draw in a triangle, and you'll see why in a second. And I'm just going to hide some of those labels. Don't need those labels. Okay, and so what we need, the question says find the sine of the angle PQ and AB. So it's asking for essentially what is this angle, PQ and AB. So what is this angle in here? What's this angle here? So you would hopefully recall from some alternate angle theorems that this angle here is the same as this angle down here. So this is why I've created my triangle like this. Okay, I know that this length down here is 5. So let's do that. If I go to distance or length and then select this part, it should tell me that it's 5. And then if I select this part, well, this x-intercept here is actually at x equals 2.5. So this distance of this line is going to be 7.5. Now, the way I was able to work that out was just substituting in y being 0 into the line 3y equals 2x minus 5. And so that gave me an x coordinate of 2.5 there. And we know that this is at 10, so that's 7.5. Okay, what we need now in order to work out this angle in here, which is equivalent to this angle, is what's the length of the hypotenuse. So we're just going to apply some Pythagoras. So we're going to do, so we know that c squared equals a squared plus b squared. So c squared equals 7.5 squared plus 5 squared. Okay, and you'll see what that actually becomes is 5 root 13 on 2. Now that probably seems a bit out of nowhere. So what we'll do is we'll use our calculator and see where that comes from. So if we go to main, clear all, okay, the square root of 7.5 squared plus 5 squared is 5 root 13 on 2. So that's where that exact value has come from. If I want it as a decimal, it's about 9 and a bit. So we can see that that's the length of C. Okay. Now, we know that sine is equal to opposite over hypotenuse, just from our trig ratios, opposite over hypotenuse. So we're going to have to take 5, which is this length here, and divide by 5 root 13 on 2. And you know, when you divide a fraction, you multiply and you flip it. So this becomes 10 divided by 5 root 13. And then the 5 and the 10 cancel out, so it becomes 2 on root 13. So you can just follow that out with a pen and paper and you'll get that result. Okay, the last question says, hence, show that the length of the perpendicular from A to the line PQ is 8 root 13. Okay, so there's a line that's perpendicular to PQ from A. So let's put that line in. If I go perpendicular line and click on this, and then it goes through A there. Okay, show that the length of the perpendicular line from A to the line PQ is 18 on root 13. Okay, what we can do here is let's just give some names to things. We're going to call this side length here from A to this point here. We're going to call that X. Okay, and we actually also know that this angle, no, actually, rather, we'll say we know that this length is 9. Okay, so what we can say is the following. Sine theta, which is this angle in here, which is what we worked out before, is equal to, so sine of the angle is equal to opposite over hypotenuse. You know, we've got this right angle triangle now. So this angle here, opposite over hypotenuse, is equal to x over 9, you know, opposite over hypotenuse. But we know that sine of theta is equal to 2 on root 13. So just replacing this sine of theta with 2 root 13 and then rearranging to get x on its own. So it's going to become 9 multiplied by 2 on root 13, which is 18 on root 13. So this length here must be 18 on root 13. So that one's a bit tricky, but let's just, you know, I just want to make sure that it's clear that we're dealing with right angles here. So let's do angle. You can see that this angle here is a right angle. That angle there is 90 degrees. So yeah, we're dealing with a 90-degree angle there. So we know that that's 9, that's x. We know that sine of the angle is equal to 2 on root 13. So you just rearrange that and then you get what it asks us to show. So hopefully you found that useful. It's a bit of a trickier question.